Okay, good to go. So Thursday is a midterm, right? I hope you guys started thinking about it already. So today we're gonna spend the lecture solving a midterm from previous year, just to give you a taste of what is coming. At a high level, as I was saying, midterm will be on grade scope. However, you have to be present in the room to take it. And we will walk the room and check your ID. So you have to bring an ID as well. If you forgot an ID, don't worry too much, as long as you can confirm your identity somehow. We can probably look up your rooster or stuff like that. But the idea is that if you're not in the room and didn't make a prior arrangement with us, we will not count it, right? Just to make sure that people don't take midterms remotely from home, collaborating with whoever they want. Again, so you need to bring a device to answer on grade scope. If it's a huge problem for you, then we will print out your paper copy, but we don't plan on it. But again, let us know in advance that if you don't have a device. In general, we will also assign seating just to prevent collaboration between friends. So we'll create a map of the room and put a piece of paper with numbers. It's a little hard here, but still doable. What else? As I was saying multiple times, it's a pretty open exam, meaning that almost everything is allowed, right? So the only things which are not allowed is you cannot open a Google search and cannot start searching online, and cannot use AI tools just to the answer should be original, your own original answers, and you cannot communicate with anyone inside or outside of the room, right? That's basically 3 rules, and then everything else is allowed. So if you want to open a lecture slide deck and check what's going on, feel free to do so. Like if you want to open a Intel manual, go for it. If you want to search through the Google through the Intel manual, sure, go for it. If you really don't remember how a specific instruction will work, and you say, "Look, can I look up on Google?" Raise your hand. We will allow you to search this instruction. What else? Of course, you can compile or run programs. You can use any tools like Code Inspector to look at the disassembly. You can use objdump, stuff like that. So go for it as well if you want to confirm your answers or anything. You can run GDB, anything, right? So any other questions? Like, I think I listed everything. Yeah, totally. Yeah, anything you like, personal notes, everything. Just 3 rules: no search. The reason for that is that when people started searching, the answers became ridiculous. They're made up. It's pre-chat GPT. Google was the tool to get a random answer from Quora or something. And so we said, okay, it's just too much. It's insane to grade, and plus it's hard to convince people you're wrong because there's like a lengthy piece of text which means nothing or unrelated to the problem. Same for chat GPT, and communication is obvious. Everything else is allowed. Yeah, and if I didn't include something in the list, raise your hand and say, okay, I want to do this. Is it okay? Sure, go for it. And we will enforce the rules by walking in the room, right? So just checking your screens and stuff like that. Any other question?
I use Compiler Explorer.
Totally, yeah. I mentioned that this Code Explorer, yeah, that's a good tool. You should share it on, I don't know, somehow this year it wasn't on Piazza. Totally, yeah. Even on previous exams, if you have answers, and I don't release the answers. Sometimes we do. It's just a burden. But if you feel like collectively start solving the midterms from previous years, posting answers online, this is all allowed. So we have enough questions to ask that for homeworks, we cannot allow this because homeworks are somewhat unique. Because if I ask build the shell, there's only one way. There are multiple ways to build a shell, but the simplest way is usually just one way. And the same for boot into x86 or boot into Hello World. It's hard to assign similar, equivalently powerful and impactful homework. That's why we didn't do that for a couple of years. And then by the time we forgot that we assigned a certain homework, we realized that it's assigned by 55 other universities in the world, and we cannot assign it anymore because it's released all over the place as well. So yeah, so that is, but the content, probably not. There we'll have page tables in the exam, but no homework. No, like the way, yeah, it's unfair, I think, to ask about the homework 3. But yeah, so not on the midterm. Kind of, yeah, the lectures, but maybe not, because it's similar to this homework 3. So I don't like to ask questions before you answer, before you did the homework, because that means that you have to study something abstract. What is lecture 7? I forgot. Page tables. Yeah, let's end it at lecture 7. So I like to ask questions about page table and segmentation. Yeah, so I don't think we will ask anything about the sequence. But just to be fair, maybe look through it. Any other questions? All good? Okay, so there is always this question about grading. And so in general, historically, not just grading, but I mean, first of all, a couple of things. So the exams are relatively hard. So it's not like, okay, you showed up and you just like answer stock kind of like boring stuff, right? So the questions, and as you will see today, or maybe you already looked online, they kind of challenge you a little, right? The reason for that is that I like to, first of all, I like to challenge you, right? But second, it's not to prove that you guys are not smart or anything, right? Or I want to give you a bad grade. Because in the end, if you look at the distribution for the grades for this class, I kind of argue that it's very, very permissive, right? So the number of A's people getting in this class and A minuses is just, probably higher than many other classes. But the exam will be rigorously graded. And just to illustrate the point, so this is the picture of my dog, right? And if I ask you a question, so which picture do you like more? Left or right? Yeah, I like them both because I like my dog, but the picture on the right looks better. And the reason for that is why? Because what's wrong with the picture on the left? It's what? It's what?
No contrast.
No contrast is the technical term is it's overexposed, right? So if you build a histogram, the thing which you see here, that the result which you get from this picture, the information is like all squished together here. Everything else is basically white. And this is a more kind of like even distribution of colors, right? And this is how you take pictures, right? So I don't know if you ever dialed the aperture and stuff like that on your camera, but it's the same for the exam. I don't want to have this histogram where everyone gets A and I cannot even distinguish people. So that's why the exam from last year, this is the distribution, right? So don't get scared, right? So what is this? The max was 90 points. The max achieved was 88, but the median was somewhere around 37 or 40, right? And like again, like I'll give you a chance. So this is where you are relative to what I expect you to know, but in the end, it will not affect your grade dramatically in this class because everything will be so permissively curved that I wouldn't worry much about the grade. Although I would still prefer the median to move here, right? So make sure that you prepare for the exams, right? Any other questions? So just don't take the grading too personal or anything, like not too personal. Don't get upset about it. I'm like a photographer, wanted to see this. I want to see this 10 people or 15 people who do really, really, really well in this class and they like study. But essentially, probably the A cutoff, I forget exactly which grading scheme I put online and what is A in this class. Does anyone remember? It's on Canvas. Anyone remembers what A was? Just to make sure that no one is worried about it. Let me quickly look it up. Yeah. Sorry, just give me a sec. Grading. What do I do here? Settings. Grading scheme. So A cutoff is 90, A minus is 81. So essentially, roughly speaking, if you are somewhere on this curve and you are doing 81, you're good. That's the point, right? So that's your like still, yeah, it doesn't work, but don't worry, you'll get A's. That's the point. Okay, any questions about this? What is it like, what I wanted to illustrate about the grading scheme? That really like, but the C cutoff is like 37 or something, 29, 29 is C minus. So again, it's impossible to fail this class. So even if you do something like, so this is like, these people essentially failed, right? So we have only like 17 people failing out of 135. This is like C minus, according to the grading scheme. Okay, questions? All good? Okay, let's go forward and start solving the questions from the previous exam. So we have a flavor of what's coming. So question number one, it's not super surprisingly hard. So it says, okay, it's a question about the operating system interface. It just asks you to build the T program. And the T program essentially takes the input from the standard input, which is here we use a pipe, but any standard input, and essentially puts it, duplicates the output to duplicates the input to standard output and a file specified in a command line. So essentially it will write to two things. And you have to write this program, right? And just to make it more fun and more interactive, let's do a poll. I have a question which asks you to do this online, on poll everywhere. It's an open-ended question, so we'll try to grade it to make sure that you guys anyone remembers how the self homework assignment work and what system calls you need to use? Let's sit for a couple of minutes on it. Well, like a couple of examples which I see here as answers. I mean, like today, despite the fact that this is asking for participation, just let me clarify this. You are expected to write the pseudocode. Your code doesn't have to be 100% correct or compilable, but it has to be like real system calls, not the answers like, I will do something, right? So the answer like use fork and pipe on this example will get 0 points. Just make sure that, again, you provide a meaningful answer. Maybe I'll look up a couple of answers with 0 points meanwhile to illustrate you, because I already looked up some good ones. So anyone is ready to stand behind the answer? So it's a little hard to type. Somehow I don't see it, like, unless I misinterpret. Okay, so okay, let's wait for a little. So, like, is that polling everywhere just allows you to type one string, or what's the problem with answering? You cannot? Yay. Okay, so that's a torture. Okay, sure. Then, yeah, then don't bother. So we'll like, let's take a, like, just in the interest of, okay, so who has the idea how to do it? Let's just discuss it verbally. And meanwhile, you people can submit. So what's the first line in this program? Anyone?
Pipe.
Pipe. Why pipe? That's one way to go about it. I don't think we need a pipe, so let's work. You have to read from standard in. Okay, sure. Okay, yeah, and okay, keep going then. Mm-hmm. Uh-huh. At a high level, I agree with you. I'm a little bit, I would say the answer is a little messy, but let me show you a good answer. Okay, let me reiterate. So, okay, first of all, let's figure out that we don't need a pipe. At a high level, this program just simply opens a file, which is for whatever we pass as an argument. So it has to, like, arg1, which is the first argument. So you open it, right? And you say, look, I will open this file, and I have a file descriptor. And then you just simply implement a loop which reads something from the standard input, which is standard descriptor, which number? Do you guys remember? 0, and write to two things. So it's a simple loop. You read from 0 and you write to two things. One, and a file descriptor which you opened. And at the end, ideally, you need to close everything, right? But maybe it's not even required. And specifically, sure, this is what the student which gets the, like, all the, like, full grade for this answer, that's what they are doing, right? So it's very, very simple. So no need to overthink, but you need to understand how this interface works. So they open arg1, and I'm not saying that this code will compile, but it's reasonably close, right? They open arg1, they get a file descriptor here. Well, they say, okay, now it's an initial condition for the loop. We say read something, or specifically read, like, they use a temporary one character. Not ideal, but they say, okay, I will be reading one character and writing one character. So they read one character from the standard input, which is 0. And until this, they are watching until the end of the line here, which is a little odd. I would rather watch for, like, failing read, meaning that read essentially read nothing, which means that the input is done, right? So this is slightly incorrect. But it's okay. We still, like, don't downgrade people on that. And then we will just, like, write to two things. They write to standard output, and they write to the open file descriptor, right? And then again, in a loop, read the next character, right? Again, kind of disagree with how the loop is handled, but fine. And here they close the file descriptor pointer. So that's the answer. More or less correct, right? Reasonably simple. Again, I'm not asking, like, nothing is extraordinary is needed.
So, as long as this
Yeah, you can come up with any pseudocode. It doesn't have to be, like, strictly C, but it has to be code. Like anything what, like, a person like you and I read as a program and say, yes, that looks correct. So if you don't remember how to use, like, arrays in C, like, something like this or whatever, put a size here, it's okay. We will not downgrade you on that. Like as you see on this got them the full credit. Python is a little, no, like if you say something, if you really say like, I forgot even the syntax in Python, but if you say something like fread, that's a little too much. So I would like to see the interface close to C. But it doesn't have to be. I understand that no one is an expert in C by now. So you will be okay with a C-like code. And maybe I will more explicitly provide instructions here that I'm asking for something C-like.
Somewhat similar. Can we access from the exam?
Yeah. And again, because I'm not trying you to like remember some nonsensical stuff. The main kind of line, and then that would be my preferred answer. You say, look, instead of searching on Quora, you say, look, I will read the man page and quickly understand how it works, and then I'm done. And you can read the parts of x86 source code, like remember the shell homework. You quickly read like how file read write works, and you're good.
Do we have to do it on the command line? Or?
If you plan to like search for man on the web page, raise your hand and alert us to make sure that we know what's going on. Good. But yeah, good question. Okay, everyone is on board with this? All good? Let me show you an example of an answer which got no credit. There is a lot of like something, right? The person decided to copy paste some nonsensical code in this box. What they're doing here, they creating a pipe, they forking for whatever reason. Maybe they misunderstood the question and they were trying to implement specifically this command, something like that. But we gave 0 credit for that. If you see that, but essentially like copy, like the point, it's not to like specifically criticize this answer, but just don't copy paste some random things. Most likely that person just misunderstood what the question is, and maybe they can appeal and we even give partial credit for that if they say I was building something. That didn't happen probably. Okay, we got this one. So question number 2 on the exam. So it was this. This is a C and assembly code for the string copy program. So I literally copied it from the x86 source code. And string copies one string into another. So essentially just a copy string function. In C, strings are represented as continuous arrays of bytes. Each character is a byte that end with a 0 or null to designate the end of the string. So it's kind of like if you have hello, then the last will be 0, right? Okay, cool. So we understood it as a function. It's like what happens here is literally just saying you have 2 strings, source and target, right? And you essentially saying until I encounter, until those guys are not zeros, keep copying. Again, a little bit. What is going on? What are we doing? And max size, the size of the string has to be greater than 0, right? And you padding the strings with zeros, which is, okay, sure, if you like it, but doesn't really matter. Again, like the fact that I picked a specific function is just to make it more concrete. So don't get hung up on what's going on here. What's important in this question is this assembly code. Essentially, I will ask a range of questions about this assembly. This is disassembly of this function. And again, this is like, again, from if you build x86, you simply will get the same disassembly. So the question number 1, which I'm asking is, what happens if you replace a function at address 190, or not a function, instruction at 190 with a no-op instruction? No-op does nothing. In other words, it advances the instruction pointer to the next instruction, but does not affect memory or registers, right? So what happens if instead of this push, we have a no? That's the question. We won't be able to return to the caller. Okay, so why? Uh-huh. And so what will go wrong? Where will you fail? So here, since if you didn't push EBP on a stack, because this instruction pushes EBP on a stack, this EBP value will not be on a stack, right? So when you reach this line, which pops the EBP, right? Instead of popping this value, you pop the return address, which sits above the EBP, right? So return will be loaded into the EBP register. And next, when you return, invokes this ret instruction, instead of returning to this address, it will return to the address which sits here, some kind of some random constant which sits on the stack, right? And so what happens after that? What? Most likely a segmentation call, but not guaranteed, right? So sometimes maybe it so happens that their address is mapped and you actually start executing instructions from those addresses. You might end up running some infinite loop, but in most cases, segmentation fault is most likely. Agree with this? Everyone understood what happened. So we just essentially, we didn't push the EBP. And so the stack is misaligned and you just essentially just start executing random code right after this ret, right? Maybe even this address is not mapped. Another possibility, maybe the stack, it's at the very top of the stack page. And when you even try to do a ret instruction, fetching memory from this address, you just simply do a stack fault right there. That's another option, right? Agree? Let me show you what the students are answering. So again, this is the answer which gets top credit. So they say the previous value of the EBP will not be preserved on the stack. When the string copy tries to pop EBP at address at line 1D9, so here, right, 1D9, an incorrect value on the top of the stack will be loaded into EBP. So, but more specifically, it's a return value because then the ret instruction at the next line will try to jump to an incorrect address and will likely seg fault. Again, very short answer, but very concrete, right? So no need to I will appreciate if you go through all the options, but even this gets the full credit, right? Good. Next thing. Same as above, but now you put no instruction instead of instruction at address 1B7. So 1B7, I hope you can see it, it's this one. Actually, you put 2 because this instruction is 2 bytes. This is jump equal instruction. So it's 2 bytes and you put 2 no-op instructions instead of those bytes. Then what will go wrong? So for this, you need to understand the flow of the code in this program, right? Which is a little, I mean, it's not super hard, but it's required. So you have to read through the assembly and understand what this jump equal instruction is doing. So what do you think it's doing? It's what? Can we see the code? Yeah. Which probably, I don't know, let me, so that we maybe quickly copy to make sure that we have it on, we have both on the screen. The code is this. Do this. Just like this. Oh, just real quick, just a sec. Yeah, it's impossible to answer. Just a sec. Pop. Put it. So this is the string copy. This is the code. I'll put it here on a side. And we can go back to the slide deck like this. Then you have the code and the assembly in the same place. I agree with you. So this question, I agree, it's a little more complicated than I would ideally like, just because there are multiple conditions in this loop. So, which kind of like confuse you, right? But most likely, essentially what you're saying, if we are, sorry, it was a different, if we're replacing an op at the address 1b7, and again, I'm not like, will not like torture you on like what will exactly, which condition will fail, but most likely the function will fail to terminate and will either run forever or will run until it start touching the memory, which is unmapped, and will result in a seg fault, right? Because you're kind of like advancing through two strings, and sooner or later you spill outside of the string because you're incrementing the pointers, and at this point you will get a seg fault. Agree with this? So this is what the student is saying. They say the first while loop will not exit when it encounters a null character at the end of t, causing it to copy extra garbage into s instead of zeroing out the remainder of s. Or, as I said, it might seg fault if the moment it starts accessing memory outside of the screen. So variety of those answers get a full credit, but at least like the flow with is along those lines. Any questions about this? So what's required here is the ability to read basic assembly and understand what's going on. Although maybe the loop condition maybe is not a really fair question because it requires too deep understanding of what's going on. But the next one is okay. So this one. Again, same as above, but we put an op instruction instead of the instruction at address 1d7. So 1d7 is this one, which pops EBX. What will go wrong now? I can try to zoom in a little. Any versions? Correct. So it's exactly, in fact, I think it's like too close to the first question because you say, look, instead of like popping the EBX into the value, into the correct register, you're ending up with a misaligned stack. So essentially the moment you start returning, you will, instead of returning to the, and this kind of specificity is required. So instead of returning to the return address, ideally, I would like you to say, look, guys, instead of returning to the return address, the whatever on the stack will be still EBP, right? And so when you invoke a read instruction, you will return to this address, which means that you start executing on the stack. And here, depending, it's kind of like an attack, right? So at this point, you say, look, if you want to be very, very specific, which is not required, you can say, look, by the way, you can guess which instructions will be interpreted in the stack, but maybe that's too hard. But most likely, essentially, that's enough to answer. You start executing instruction on the stack, which is the complete garbage, and you're gonna result, it will result in a seg fault sooner or later, or maybe again hang your program in an infinite loop if these instructions are like somehow happen to be some kind of a loop, formal loop, which is like never exits, right? Make sense? So essentially, this set of questions is about the calling convention. So essentially saying, okay, we understand what the stack is about. We understand the basic role of these instructions like return and stuff like that. And so we understand how the program works and we understand what will go wrong. Let's check what the student is saying. They say at this address, string copy will pop the last pushed value into ESI. But this value is the saved value of EBX. This is not correct. And it will similarly load the saved value of ESI into EBP and leave the saved value of EBP on the stack. So they are pretty detailed about it. The read instruction at this address 1DA will then try to jump to the saved value of EBP and will very likely seg fault. So that's good enough, right? Any questions about this? All good? Okay, good. Question number 3. Below is the code snippet of the cat function from the x86 cat utility. So cat is the one which reads something from the standard input and puts something on the standard output unless the argument is specified. So let's take a look at what is asked. Memory allocation. So for each variable used in the program above, explain where either on a stack or a heap or a data or a BSS section, this variable is allocated. So let's try it again on the, let's try it again on the poll everywhere. So let's activate it real quick. Let's see what's happening there. This is relatively easy. Man, I got 93 responses. I don't believe there are 93 students in this class. For previous question, because I did not close it, which is fine. At least people are trying to participate this, which is cool. And again, for people on what is it? People in class and on Discord. So just make sure that you put meaningful answers. So this time we'll probably grade manually. And unless you put meaningful answers, you will not be for correctness in this poll everywhere. So everyone has a version of the answer. Let's start discussing. Is it a little too small? Okay, let's start. What is the first variable which we see on the screen?
Well,
Yeah, where is it?
yes,
Yeah, it's in a data section and more specifically in a BSS because it's initialized, so it will be in a BSS. Agree with this? Okay, good. What's next one? FD, so this one. Where is this one? Correct, it's an argument, and the calling convention tells us that it will be passed on a stack, right? So this is on a stack. What else? Which next? Which one is next? N, okay. Where is N? Stack. That counts as a correct answer, but maybe if you want a job at a top company, can we refine the answer? Data? No, it's a local variable. So the first guess that it's on a stack is correct. So stack counts, BSS and data don't count, but let's, people who look at the code explorer.
allocates local variables within functions by decreasing the stack pointer in order to make room for the variable on the stack.
That's correct. But did you read assembly code? Once in a while, you don't see this. Correct. So sometimes compiler is allowed to optimize and put it in a register. Again, for the purposes of this exam, stack works. But again, like if you want to be like top performer somewhere, you should really give an answer. But I've seen a bunch of code where N is like in some unused register. And most likely it will be the caller saved register because you don't have to save it. Cat is not, because it's a label in an assembly code, right? So it's just, it doesn't exist as a variable. So we're not using it as a function pointer, right? And the student who answers gives this answer and we give full grade for this, right? However, I want to again, like if we're really shooting for like top jobs, which you guys deserve, what is missing here? Or you have a question?
I think pointers to the string curls, which should be initialized.
Totally. So where do these guys sit?
They're the data strings.
I think they're actually in the data. I don't think the string specific section, there is a specific string section. I can be wrong. The string section in ELF, it's a strings to preserve the names of the variables, I think, but I'm not sure. But you're right. But let's say data section. Good. So this is what I was asking for, and a couple of others. Let's identify other variables in this code. But where do you see function pointers here? So this, when you call a write function, it literally compiles into call assembly. It will be called write, but or I mean, like yeah, but in a machine code, call some address, right? So it's not like a variable.
So the value of size of buff.
Clever. I think you're right. So this will be 512. Will be done by compiler, but is it a variable? I agree, but it's an argument, and maybe we should say that it's on a stack. No, but really the compiler will generate something like I'm like, it depends on which, like literally it will be call address of read, but then above it there will be a push of FD, which was on a stack, something EBP minus something push of a buffer, which is a local, a global variable, and there will be a push of 512. Just again, like, just make sure that you understand that literally 512 will be present there in the code. It will be pushed on the stack to follow the calling convention. And a final one, this once here, there will be there as well. And then, like, as you say, this is good enough to answer this exam. I'm only pushing you forward to make sure that, you know, if you ever like see this elsewhere in your life, you can look through and say, look, I got it. So like, I got that there is this, like, you need to understand what this converts to, what this one converts to, and stuff like that. But overall, yes, good. And I'm happy that you guys figure out that the literals are in data section, 512 is there, stuff like that. So that's good. Okay, next question. So which lines in this code will require relocation if loaded at a different memory address? If the program is loaded at a different memory address. Oh, let me close the poll. Otherwise, I will get again. This one is still. What am I showing? This one. Okay, let's start. So cool. Which one? Which lines? Okay, but Loic, like, pick a line, pick a victim, and let's discuss the line. 5. Okay. So does this line need relocation or not? Not. Okay. You know, I know how to hint the right answer. Why not? Who can explain?
That's just a very
Correct. So this line, and that's important to understand, it just preserves the space in the data section. And it reserves this 512 bytes, but you know, like, you can load anywhere this data section, since it's important to remember that we need to relocate when we have a move instruction which uses the address of this buff. So for example, we're loading the first byte or the first 4 bytes from the address buff, those 4 bytes into the EAX register, right? So if we have such instruction, then we have to do something with this address, right? Because the buff can be not at address 55, but at address 155. And now we have to change this address, right? And again, go ahead, like, I encourage you to use any tools which you can come up with. Code Explorer or OptDump will give you all the relocations. But again, the goal is to understand how it works, right? So this line number 5 doesn't trigger a relocation, right? So let's pick a different line and discuss it. Line number 13. Okay, what requires the relocation here? The use of buff is a global variable, so this is exactly kind of like when you pushing, like this line will create the code which is call override, and it pushes the first argument is 1. It will push 1 on the stack, then it will push, before that it will push the adder of buff, and these adders will be changing, right? And the size of n, okay, and it will be pushing n here. Do we need, like, first this line? So do we understand that the use of buff will require relocation, right? Everyone is clear on that? What about the use of n? Like, tell us then.
Because n is located on the stack, which means that its location is found relative to
yeah, EBP or ESP. EBP minus whatever, or plus some X, or ESP plus or whatever, plus some delta here, right? So correct. So this code will not require relocation. In this code sequence, do we see any other relocations? What else is needed? Not all, but correct. And exactly. So you say this is an external function. It's not defined in this file. It will be coming from one of these, right? So I don't exactly remember which one, but this is an adder, and compiler originally just maybe put zeros here or whatever, 0 f, some negative number here. And this line will require relocation, right? Because the write will be essentially linked later. Compiler will put an address, but if you load it at a different address, you have to update the address of write, right? Exit?
Yeah.
In x86 you do, and you're right. So functions like exit, printf, write, read will all require relocation. So all these lines have to be mentioned in the answer, and just make sure that you are specific about what's going on. Like in each line, which variables are triggered will require a relocation. Any other relocations? Correct. So because string literals, we just identified that they are in a data section. So when the compiler generates a call for this printf, I mean, printf is a funky function because it's variable argument, so it's a different convention, but nevertheless, like this string, address of this string will be in a data section, so it will require relocation. So this too. Agree with this. What else? At this point, I don't see anything, but maybe I'm wrong, and maybe you guys know something. So size of is a language construct, so it doesn't require a relocation. Compiler will generate a constant here. I think that's it. So, like, of course, n is on the stack, so it doesn't need a relocation. All these ones are constant, no relocation. Like, yeah, so this constant variables. So sure, yeah. Any questions about this?
Why did you say when it's linked?
When it's linked, compiler will replace when you let me just erase for a second. So when, for example, when you call this write function, when if you like this cat function will generate an object file, right? First, you just simply compile .c into .o, right? And compiler will put something like ox, f, some f's here, some predefined address, but it doesn't mean much. So it means that relocation is required. not even relocation, just this function, the right is the position, the address of right is not even known yet, right? So you just can't do better. And then when you link this like object, your cat.o into something like with the local libc, which provides the implementation of right, at this point, it will merge the text sections of cat and the text section of libc. And this line, imagine this line is somewhere here, will be replaced with a correct address of right? So at link time, we will get one executable program. But however, if you want to, and in x86, it will be linked to run at address 0. If you want to load it at a different address, like let's say 0x first megabyte, then you probably one more 0. Then you have to essentially relocate all this addresses, right? So let's imagine the link, we passed the linking stage. It's easier to think about it, just not to make sure that we are not confused about it. We're just relocating to be able to run this program at a different address. Make sense? Any other questions? You like I got half of it, so can you say louder? I don't think so. I think that's it. I can be wrong, and compiler may generate some funky stuff, but probably not. I don't immediately see anything else. So global variables and or variables which are like technically speaking, this you can argue that maybe it's a local variable, it's just that the C places it in a global data section. We have to read the C standard carefully to understand it. But just remember that this is what C does. External functions, local functions. I don't think I will be like, if there is another function foo, and if you call foo here, a good student will argue that most likely this is a local call and will not trigger a relocation, right? But this is so kind of like into the details. Just again, for those jobs interview, I think a compiler will, if you put static here, it definitely will make it a local function because it will not be visible from the outside. If you don't put static, I think it's actually an exported symbol, and then I don't remember how the code is generated, but just check for it later maybe.
So how can the answer be different if we use position?
Oh man, that's a good question. In position independent code, obviously. Okay, good question. So you guys tell me. So how is the answer changes if you use position independent code here? Does anyone remember even?
So in the you require verification when
Correct. But essentially what the compiler will generate is all of these calls and references to global variables will be like references to global variables will go through this global offset table, and essentially the address of this string will be placed in a global offset table, and that's how the relocation will be done. Something what I didn't cover in the class, the calls to functions, or I did actually, right? We'll go through something what is called procedure linking table, PLT. And again, like remember those, there is a jump to the trampoline figures out where the function is, and then like patches the table in a lazy manner, sorry. Yeah, ideally, yes. So it would be nice if you know it. I don't think I will go into the position independent code on the exam, but I might, since you reminded me. That's a good idea. No, but this is like, that's the reality of life. So this is what you will see. So people you're interviewing for a job. I mean, of course, I get it. So there is a variety of jobs, and who knows what you're going to be interviewed for, but this is one direction. People might ask you that. So if you're here in this class, it makes sense to learn it. Any other questions? All good. So we got relocation. So more or less, this is the answer. So the person here just goes line by line. So let's not spend time here. I'm pretty sure we captured everything. That's the full grade answer. Now, question number 4 in this exam. It goes like this. So imagine you have an x86 machine, which has all the same instructions that we discussed in a class, besides that it does not have call, read, push, and pop instructions. Imagine you are in control of the compiler and can generate any assembly code you like. Explain how can you support function invocations. Show an example of an assembly code that invokes the foobar function with 3 arguments. How will you perform this invocation? The question says, okay, like these 4 instructions are disappeared from your instruction set, replace them with something else. So let's make it easier. So instead of a call instruction, what we will be doing? Step by step. Okay, I agree with you. So instead of you just replace the single instruction with a couple of other instructions. So you jump to a foobar and you say, look, and by the way, I will, since you don't have a push instruction, right? Yeah, so instead of a push, you will do something like a move on the, either you say something like add or sub ESP for reserving a space on the stack, and then moving ESP. Imagine the compiler is smart enough that it knows this address A, and you essentially just moving A on a stack, right? Agree? Question? This is what I'm doing here. So I'm just it's the question is like at the level of the compiler, you will know this address, and or you can, but the question is that you really cannot read instruction pointer. Otherwise, we would say EAP plus 5, which would be like, which probably is still a good answer, because you say if we don't know this A, it should be just EAP plus 5, or like I don't know whatever, like it's maybe if jump is shorter than 5, then something else. Ideally, you need to write this. If you're clever enough, you can say, you can do a trick from the position independent code to figure out EAP and then push it on the stack. But as a simplifying assumption, you can also say that I assume that I know the address, the instruction right after jump. But you're right. So this is the good kind of clarification. But along those lines, right? Agree that this is how we kind of replace the call invocation. Now we have to put the arguments on the stack, but that's much easier, right? We again reserve some space on the stack by subtracting something from the ESP and then just moving those arguments on the ESP, right? Agree? What about the return addresses or return? Oh, it only asks, show an example of the assembly code that invokes the function. Okay, that's enough then. Okay. Good. So let's take a look at what the student is writing. So they're writing something like this. They say the assembly was, the x86 assembly is push 3 arguments on the stack, call foobar. Here they say, look, we will do the same, ESP minus something. They assume that they can access EAP. That's totally fine. I mean, we didn't downgrade people on this. Like, it's fine. It's like this detail is minor. Again, if you're interviewing for your dream job, maybe make sure that you can explain that EAP is not accessible on, you cannot access EAP on the x86, and you can do like a call of a next instruction, which is A here. Call is disabled, right? You are. So I don't even know what you do then. Good point. Yeah, call is disabled.
So I don't know if this would be accessible. What I was thinking is instead of the IP, which is not accessible, could the compiler know what the return address of the function should be ahead of time? And
Yeah,
put
yeah.
that hard-coded into the
Yeah,
stack?
yeah, and that's what I assumed here. This address
Okay.
A is like,
Oh, I understand.
yeah. So sorry, I was maybe moving too fast through this, but yes, I assume that it's a little, but I mean, there is a variety of those answers. So I'm not like, again, at this point, you know, the question is a little tricky. So the answer can be also creative. Just explain your assumptions. Ideally, the student should assume here, like put a comment for me saying, I assume that I can access EIP. I cannot do call because it's disabled and stuff like that. But you can say that I assume that the compiler knows the address after it. So what do they do here? Oh, then subtracted ESP16. Wow, that's good. They maintain the stack alignment. But I'm a little lost about what's going on here. But at some point, oh, this is important. They restore the ESP. I forgot about it. So after the call, since you know you have to, although they didn't have it here, so but it's okay. It's again, those details will not penalize you for that. You're saying, do I need to follow the same polling convention? Well, technically speaking, no. And I will take this answer as long as you can justify this saying, okay, I'll come up with a different polling convention, because at this point I'm so upset about Intel that I'll design my own machine. That's an acceptable answer. But it's a harder answer because you have to justify more things. But I would be super happy to see it. Right. Yeah, you can do different tricks, but it's easier to kind of like, I mean, I can probably more explicitly say implement the same calling convention, but you can say that. I don't think by changing the calling convention, you will gain a lot, because ideally you still need to implement the stack because you have to jump and return. So I don't really know what kind of simplification are you going after right now. Like, but it's good. It's good to explore in any way, in any case. Okay, good question.
Add the OX14.
Wow, I honestly cannot, but we just took this answer, and again, I'm saying that answers have to be concrete, but we are still permissive. My guess, and it's kind of shame that the guy or the girl did not explain what's going on. So here they subtract 16. Looks like they say we push 12 here on the stack, and they will push EAX. Why do they push EAX? Because they said that we're gonna clobber EAX here, because we moved EAP into EAX, incremented by 14, meaning that they want to be here probably, and then just jump to foo. So that's probably not necessary. So it's a little bit of a overkill for this answer.
Yeah, the thing I don't have confidence to get this one.
It's okay, but we didn't downgrade the person. I would appreciate a comment here saying 14 is this size, like move instruction is whatever, 4 bytes, sub is 1 byte, jump maybe is 5 bytes, or somehow they counted them, but I don't think they counted correctly. But it's good enough for me in this class that I appreciate the effort and stuff like that. Good. I think everyone is getting tired. Like same question, so maybe let's not spend so much time on it, because I have one more flavor of these questions. So it asks, how will you maintain the stack frame and return from the function show assembly code that maintains the stack frame? Essentially same idea. They write something like this, which we took. So essentially just the same logic. So I don't want to spend time on it. Let's just move to the next question. My next one is about page tables. So, right, there is always a question about page tables or combination of segmentation and paging. So, and the way we ask those questions, it's kind of always in the same format. So we kind of briefly describe the page table hierarchy. We say, consider the following 32-bit x86 page table. CR3 holds address 0, page directory page, the physical address 0, so this is the root of the page table, has only 2 entries, entry 0 and 1, everything else is 0. So this one, page physical page number 1. So essentially, if you stumble, you can draw those pages. You say, look, CR3 points here. This is root. Then 2 entries, 1 points to 1, and the second one points to 2, right? It's very easy because we say, look, page table page at physical address 1, ppn 1 is this, and this is this one. And the second one is this one. So this is address 0, this is ppn 1, and this is ppn 2. Like we give you the entries, right? And then the question says, specify all virtual address ranges mapped by this page table. Don't forget to mention the physical ranges for which virtual range is mapped. So for example, the answer should look like virtual from A to B is mapped to physical from Z to X, right? So how do we go about it?
So each virtual address is split into 3 portions, which are the 10 bits PDE entry, page table entry, and the 12-bit offset. So for the first one, the first 10 bits can either be 0 or 1. Those are the bits mapped there. If the first 10 bits are 0, actually in either case, the second 10 bits can also either be 0 or 1 because we have the other 2 page tables mapped to those. So that gives us our virtual addresses. And to get the physical addresses, you just kind of follow the page tables. So 0, 0 goes to physical address with that 3, 0, 1 goes to the physical address of 4. And
okay, I agree with you, but just to simplify and to like kind of provide a framework for how to reason about it. So this is entry number 0. It maps, in theory, if all this level is completely full, then what range will be mapped? What virtual range will be mapped? Correct. So it would map virtual addresses from 0 to 4 megabytes. And this is how to think about it. That the one entry at the page table directory potentially can map 4 megabytes, right? And this is entry 0, so this is address 0, right? And obviously entry number 1 here will map potentially consecutively map from 4 megabytes to 8 megabytes, right? And now we kind of go backwards and prune because we say, look, your way of going, it's completely fine, but it's just a little easier to keep this in your head because you first imagine, you say, okay, which is the entire range mapped here? And you say, well, no, only 2 pages are mapped because everything else is 0, right? So literally only these 2 virtual pages are mapped. Page number 0, page number 1. So it's addresses from 0 to 8 kilobyte, right? And similarly here, so it's, sorry, I said this one, oh, that's correct, this one. What about the second one? The second one also has only 2 entries. So again, only 2 pages are mapped, right? So it's page number 4 megabytes plus nothing, and 4 megabytes plus 4 kilobyte, the second page. Agree with this? So it's kind of much easier to visualize it this way, right? So we figure out the virtual address ranges. So it's just 2 ranges. And now the question is like, where are those mapped? And now you look at these addresses. So this is consecutively maps this page to ppn3, which is a physical address 0x3000. And this one goes to 0x4000. So page number 3 and page number 4. And this one is mapped to 6 and 7, right? Yeah. So 0x6000 and 0x7000, right? And that's about it. So I think that's the answer. Make sense? So just convert those into the ranges. Let's see what the student is saying. They kind of miss the fact that those 2 are consecutive, right? So, and the physical addresses are also consecutive, but we still give full points, but they say, okay, it goes to 4 megabyte plus 4 megabyte. It's okay to think about it this way, but those are concatenate. You can concatenate those regions like I did. Agree? Yeah, you can do, yeah. It's the exam will be rated by a human. So any notation. I mean, yeah. So this is a little bit more precise because it like gives you the last byte which is mapped, but I will not downgrade when if you say 4 kilobyte. It's fair to say. Okay, any questions about this? Reasonably, again, like the moment you know how to think about it, it's reasonably straightforward. The second thing we ask about it is the following. Using the same format as for describing the page table as in the question above, construct a page table that maps virtual addresses from 0 to 1 megabyte and from 2 gigabytes to 2 gigabytes plus 1. To physical addresses from 0 to 1 megabyte, both of them will be mapping from 0 to 1 megabyte. You are free to choose where your page table directory and page table pages are located in physical memory. So how can we do this? Like essentially, I ask you to, it's kind of reverse program. If the problem, if this page table directory, and this is page table, and maybe another page table, we need to fill in the gaps here. We'll call this 1, and this one is 2. So again, this is our virtual address space. So how to think about it, how to visualize this problem to make sure that we quickly can arrive to the answer without thinking. Well, the question, like, again, for me, it helps to visualize and say, okay, the question says map from 0 to 1 and map from 2 GBs to 2 GBs plus 1. And both of those regions will be mapped to the same kind of physical memory here, right? From 0 to 1 MB. We kind of just talked about that this first entry of the page table directory can potentially map everything from 0 to 4 megabytes, right? So sure, we definitely need to put something here. What do we put here? We need to put a pointer to the page table level 1. We're free to control the address of this. So just make up an address which you like. I will put symbolically PT1 here as an address, right? And then some flags here like present, writable, whatever you want here, user accessible here, right? Okay, so we got to this. We want to map this region. So we pick this page table 1. I mean, this is probably kind of overlaps with the homework number 3 because I ask you to construct the page table. So it makes sense at this point, it makes sense to at least start working on this homework. What about the entries in this page table 1? So how many do we need? Correct, 256, because the way to think about it, if you use all of them, you mapping 4 megabytes, and the total number of entries is 1024, but you're really mapping just 1 megabyte, so you need just quarter of those entries, right? So the first 256 entries will look like what? What do you put here?
The middle bit of it that maps to the actual.
Not exactly. So you don't put it's not the middle bit. You literally, since you're trying to map those physical pages, here you will put addresses of those pages, like address 0, address 1, but it's physical page number, so 1, then 2, and so on until you go to 1 megabyte, which is 255, right? And you don't have to enumerate them all. You just give me the answer just says 1, 2, 3, and up to 255, right? Agree with this? And in fact, the page table puts the PPN here because they use the lowest 12 bits for flags, right? So it's, you can say PPN number 1, PPN number 2, PPN number 3. Yes, that's an ideal answer. And of course, like quickly thinking, okay, since this maps to the same physical memory, so exactly the same entries will show up here, right? And so on up until like 255. Agree with this? And of course, you can like make up an address for this page table too. The question is like, which entry do we have to pick in the page table directory to map it? 10, 20, 512. Yeah, good. Fast enough that I didn't notice. 512, because 512 exactly splits the 4 gigabyte address space exactly in half. And this is what we've seen when we were looking at the system init in x86. We saw this entry 512, right? Okay, so that's this is what the student is writing. That's the answer which we took with full credit. So they say PPN1, PPN2. They picked like pages 1 and 2. Like it's okay to pick the pages which are mapped for the page table 1 and 2. This is PPN1, this is PPN2, and they go here from 0. Oh, this is wrong, but we didn't downgrade it. Okay, sure. I told you like this off by 1, we're lenient graders, but fine, right? Everything else is 0, but this is the answer, right? And I post it online. Obviously, there is no secret, so I will push this everything on the web page. Okay, cool. So I think we actually are done, which is great. If you have any questions, go for it. And good luck on the exam.